Jai Shri Gurudev. Let us discuss about center of gravity and centroid in this particular module. So, what is center of gravity? Whenever we have a whole body that has been taken up into consideration, say for example, I have considered a body like this. Now, if at all a given body, we are trying to find out the center of gravity. That is nothing but the point where the entire weight of the body is assumed to be concentrated. Then this is called as center of gravity. This is the point in which the whole body is going to be balanced about, and this is also the point through which the weight of the body is assumed to be acting. So we are going to denote center of gravity by CG or by just G. Now coming to the point of centroid. So what is this centroid? We have seen that center of gravity is taken up for a body. When coming to centroid, centroid is going to be considered whenever we have a plane figure. Say for example, I have a plane figure like a rectangle over here. So here the centroid is going to be acting at this particular point. The moment we consider a plane figure and not a body, then we are going to make use of the term centroid. Okay, so this centroid, here we are going to determine x bar and y bar. X bar is nothing but, say for example, this is the origin. From the origin to the point along x axis is going to be your x bar, and from origin to the point where your centroid is going to be along y axis is going to be y bar. So here we are trying to determine x bar and y bar under centroid. So how are we going to determine this centroid? First, let us talk about the method of moments. So here we are going to determine, we will be determining centroid, determination of centroid by the method of moments. This is going to be an overall formula that we are going to obtain. Now say for example, we have a cuboid present over here. So this cuboid is going to be considered. How is this cuboid going to be? It is going to have a thickness over here, a thickness of t, and then let us say that the x-axis is passing over here, and assume that the z-axis is over here, and let this be the y-axis. The overall weight of the body is going to be concentrated at the center of this particular given body. Now before I mark the overall centroid, let us break this body into n number of pieces. How we do it for our integration, differentiation, part to whole, whole to part. So similarly here also we are going to break down a given body into n number of pieces. Later on I am going to take up the summation of it and hence find out the formula for it. Now the overall weight of the body, let me call it as W, and let us say it is concentrated at x bar comma y bar, and then let me consider this first piece, piece 1 over here. Let us call the weight of that piece to be W1, and let us say it is at a point x1 comma y1. Similarly W2, x2 comma y2, and so on. This last piece that is present, let me call it as nth piece. Okay, so this particular nth piece, it has, let us consider that it has a weight of Wn, and it is present at xn comma yn. So once we have written all these things, now I am going to apply the theorem of moments, or the Varignon's theorem of moments, or principle of moments. So under this I can write that the net weight of the body multiplied by x bar, that is nothing but the perpendicular distance, is equal to individual weight multiplied by the perpendicular distance. So it is going to be w1 into x1 plus w2 into x2 plus w3 into x3, so on till the last point, that is wn into xn. Or I can write x bar is equal to w1 x1 plus w2 x2 plus w3 x3, so on till wn xn entirely divided by the total weight w. But we know that density is determined using gamma. This gamma is nothing but weight divided by volume, and we also now know that volume is nothing but area into thickness. Now here the thickness is going to be constant, so thickness is going to remain constant over here. Hence I am going to write x bar is equal to weight. So here we are going to write weight is equal to gamma into A into T. The density of the body is going to remain constant, so it is going to be gamma into piece 1, so it is going to have area 1. Thickness is constant, so T is constant, then x1. So this is nothing but W1 plus gamma constant, A2 area changes, thickness again constant, into x2 plus gamma A3 into T x3, so on till gamma AN into T into xn entirely divided by W is gamma into A into T. This A is nothing but this A, whatever I have written over here, this A is nothing but A1 plus A2 plus so on till AN. Now I can write that x bar is equal to, here I can take out gamma and T cancel from the numerator. Similarly from the denominator, gamma and T I can take it out. So all I am going to be left out with is A1 x1 plus A2 x2 plus A3 x3, so on till AN xn divided by, you can write it as capital A over here itself, or if you want I can also write it as A1 plus A2 plus A3, so on till AN, or this is summation of AIXI divided by summation of AI, or summation of AIXI divided by capital A. This is centroid. This centroid is along x-axis, so x bar is equal to summation AIXI divided by summation AI. Similarly, if you consider y bar, it is going to be summation AIYI divided by summation AI. This is the common formulas that are used for determination of centroid. Now the next topic is axis of references. Now if you can remember, when we were discussing about the centroid, I had written a dotted line like this. So we're going to talk about these dotted lines. So the topic is axis of reference. About some particular line or about some particular point, I have to determine the centroid. So that is what we are going to talk about now. The axes that are going to be there, if it passes through your centroid, or if it is with respect to your centroid, then it becomes centroidal axis. Now over here, centroid is present over here. So let me call this as XX and YY. So this XX and YY, XX and YY are nothing but centroidal axis, because it is with respect to your centroid or passing through your centroid. Now say for example, I am going to write 1 axis. Now this 1 axis is nothing but my reference axis or axis of reference. Okay. Now let us talk about symmetrical axes. We are going to be faced with certain types of symmetrical objects. So the topic is symmetrical axis. Under this symmetrical axis, now say for example, I'm going to consider a rectangle like this, and then obviously the centroid is going to be at the center of this given body. Let me call this as XX, and let me call this as YY. Here is the centroid G. Now I'm going to consider an eye-shaped structure or an eye-shaped plane figure. I've considered an eye-shaped plane figure. Okay, if we are going to consider that the centroid is about the centroidal axis or the axis of reference, whatever it is that you're trying to consider is going to pass through the centroid, then obviously it becomes centroidal axis. So here we have XX as well as YY. So here this XX and YY for both the figures are nothing but your centroidal axes, and plus the objects, if you can see about x-axis, let us consider first the rectangle. About x-axis, your figure is being cut into two equal halves. So your x-axis is going to be a symmetrical axis, and about y-axis, if you are going to consider, then this is also going to cut a given object or cut your given plane figure into two equal halves. So this is also going to be a symmetrical axis. Now coming to I plane figure, XX is going to cut the plane figure into two equal halves. So it's a symmetrical axis, and YY about this axis also, it is going to break it down into two equal halves. In this particular case, X bar is equal to 0 and also Y bar is equal to 0, both the cases, because the centroidal axis, we are trying to find out the centroid of the body about that particular centroidal axis. Hence, it is symmetric about it. Therefore, X bar and Y bar are going to be symmetrical. Now, let us consider an object which is symmetrical about just one particular axis. Say, for example, I am going to consider a plane figure of the shape T. So, if I consider this plane figure, I have x axis like this. This is not going to break it down into two equal halves, but the y axis that is present is going to cut my given plane figure into two equal halves. Hence, for this particular case, I can write that X bar is equal to 0 because it is symmetrical about YY axis. Now, say for example, I'm going to consider one more figure, a C-shape figure like this. So I have my centroidal axis XX like this, and my centroidal axis YY like this. So for this particular figure, we know that it is symmetrical about XX axis. Hence, Y bar is going to be equivalent to 0. Now, the other type of figure, what I am going to consider is an unequal C-shape figure. Say something like this. So here for this, if we are going to find out the symmetrical axes, there is none, because it's not going to cut down or break your given figure into two equal halves on either XX axis or along with YY axis also. So here X bar is not equal to 0, Y bar is not equal to 0. You're going to have a definite number. So here this is not going to be a symmetric axis.